This lesson is titled Horizontal Asymptotes. Now, asymptotes in general should not be a new topic, whether they be horizontal or vertical asymptotes. And even in college algebra, we talked about asymptotes and we described them with limits. We're just going to kind of further do that, so almost really reviewing and kind of reinforcing identifying horizontal asymptotes and using the language of limits to describe horizontal asymptotes. So first we'll look at kind of the definition of a horizontal asymptote, and let me begin by just drawing a graph on here. Just going to kind of randomly draw one. Something that you might see. So maybe you've got something like this. And there are asymptotes. This would be the graph of some sort of rational function. You have asymptotes here. Let's just look at the horizontal one that cuts right through the middle of this. And we'll say that this is at the line y equals b. So we're matching that. Okay. So we say that the line y equals b is a horizontal asymptote of f of x if the limit as x approaches infinity of f of x equals b, or a limit as x approaches negative infinity of f of x equals b. Okay, so what we're looking at in this particular lesson really are limits that involve infinity. And these limits for horizontal asymptotes involve infinity on the x. Okay, so as x approaches infinity or as x approaches negative infinity. And so if you think of infinity on the x-axis, that just means you're going out to the right forever. And as we go out to the right, what happens is this graph flattens out, and it flattens out at that horizontal asymptote. So the function value gets closer to this. It doesn't actually equal it though. Okay, and same thing here, just going to the left. Negative would be in the left direction. So this first example says, describe the horizontal asymptote using limits. So what I thought we'd do is just kind of combine a little bit of review and how we find horizontal asymptotes as well. And we'll go ahead and put it on the graph also. Now, it's okay for you to graph with the graphing calculators on this, so I'll go ahead and do it that way too, just to kind of share that with you. So I go into my graphing calculator, I go to my y equals, and let's just type this in, 4 divided by x plus 2. Now I went ahead and changed my window. Look at my x and y min and max. I changed it to be -6 to 6 both directions because that's what my grid on my notes shows. And if I graph that, we get a graph that looks about like this. Okay, so let me try and recreate that here. Okay, so our graph looks about like that, coming here. So what do we know about this graph? Well, this graph has two asymptotes. It has a vertical right here, and we'll talk about the verticals more in the next video to this series. It has a horizontal one right there. The horizontal asymptote is the line y equals 0. Now you will recall that anytime the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the line y equals 0. And so if I remembered that, I wouldn't really have to do this at all. I wouldn't really have to show the graph. So I'm just kind of showing the graph to combine the knowledge of this up here and then just kind of a visual picture of this so we can understand the limit a little bit better. But again, if we knew this, we really wouldn't need to see the graph. Well, so I can describe the horizontal asymptote with two limits. The first one is a limit as x approaches infinity, f of x equals, the other one will be the limit x approaches negative infinity of f of x equals, and what they equal is the horizontal asymptote. Generally, it's like this. Anytime you see limits as x approaches infinity or negative infinity and it approaches a real number, then that real number is horizontal asymptote. Next example, again, we'll use a graph of this function to help us understand where the horizontal asymptote is. So let's just begin by graphing this. Again, windows are -6 to 6 all directions. And so there's my screenshot on the calculator. Let me transfer that to paper. Kind of looks like this. Okay, this particular graph has asymptotes that are right here is the vertical. Again, we're not really interested in that in this lesson. And there's the horizontal. Okay. Now again, just to review, when the degree of the numerator equals the degree of the denominator. And that's what's happened here. Degree here, I've got first power divided by first power, and their degrees are the same. Well, when that happens, and the horizontal asymptote is y equals, we'll just say, ratio of coefficients. Of the leading coefficients. So the coefficients here are 2 and 1. Well, 2 divided by 1 is 2. That's where the horizontal asymptote is. Okay. So again, if I know this, if I remember this from algebra, this is all not necessary. I don't really need the graph. I can answer this question. I can write the limits without the graph if I know that. Okay, so the limits are this. Limit as x approaches infinity. I also want the limit x approaches negative infinity. So as we go to the right, the function's flattening out at 2. As we go to the left, the function's flattening out at 2. And 2 is the horizontal asymptote. So that's it. Last example, let's again investigate this with the graph. So x squared divided by x plus 3. Okay, so that's a little bit different than we've seen so far. Doesn't look like the same sort of rational curve that we've seen in the previous examples. What we have is a graph that is kind of doing this. Now, there is, and it goes off the graph, I'm not sure exactly how far down it goes, but there is another piece of this down here too. So there's two sides of it, just like all the other rational functions that we've seen. But this one is very different than what we've seen in the past. Let's kind of go over the rule for horizontal asymptotes on this particular one. When the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. In fact, there's what we call a slant asymptote. Slant, or you see this too, an oblique asymptote. Okay? There's actually an asymptote that, and I'm not going to actually find the equation, so you have to forgive me here, but there's an asymptote that is kind of doing something like that. And there's also this vertical one here too, and that slant asymptote has an equation. I'm just not showing how to find the equation right now, so I'm just kind of guessing where it goes. So since there's no horizontal asymptote, then I can't describe the horizontal asymptote using limits. So there is no limit statements to write here for this one, as it doesn't have any.